Today we're going to wrap up our section on the laws of sines and cosines by looking at some application problems and discovering ways that these laws are used to solve problems in the real world. Take triangulation, for instance. Ships and aircraft use triangulation with signals from beacons or towers to determine their position on the ocean or in the air. Distance triangulation is used in astronomy to find distances in space. Surveyors use triangulation to find distances for mapping. Seismologists can locate the epicenter of an earthquake by triangulating the seismic wave measurements. And GPS systems use triangulation from multiple satellites to pinpoint a device's location. These are just a few examples of how trigonometry and triangulation are applied in everyday life. Let's see if you can use trigonometry to help Mia cross this river. You're on one side of the river, and Mia is on the other side. Mia wants to cross the river by stepping on some rocks, and the two of you decide that this path is best. You plan to throw a rope across to help guide Mia as she navigates the rocks. Your rope is 100 feet long. Will it be long enough to reach Mia? Let's find out. It's a good thing that, as someone who loves trigonometry, you carry a protractor and measuring tape in your pocket at all times. To answer this question using trigonometry, start by measuring out a straight line that is 165 feet long. At one end of the line, you measure the angle to Mia's spot and find that it is 62 degrees. At the other end of the line, the angle to Mia's location is 35 degrees. Using these measurements, how can we determine whether the rope is long enough to help Mia cross the river? Pause your video now and draw your own representation of this situation in your guided notes. It's fine if you enjoy drawing features like rivers, trees, and rocks, but it's also totally fine if you just want to draw simple lines and dots. When you come back, we'll solve the problem together. As fun as a detailed drawing can be, I usually prefer to keep my drawing simple. I recreated the triangle and labeled the vertices A, B, and C. Next, I added the information I know. Angle B is 35, angle A is 62, and the side between them is 165 feet. Which side do we need to find in order to answer the question about helping Mia? Right! We need to find the length of side AC, or, more simply, B. We know two angles and their included side, and we need to find a missing side length. What trigonometric strategies can we employ here? In order to use the law of cosines, we'd need two sides and their included angle. But we only have one side, so the law of cosines won't work. What about the law of sines? In order to use the law of sines, we must have at least one known angle side pair. Do we have that here, or can we easily determine one? Sure. Triangle sum theorem allows us to find the missing third angle, and that will allow us to use the law of sines to finish this problem. Pause your video now and find the length of side B. Let's see if you're able to help Mia. The triangle sum theorem tells us that angle C must be 83 degrees. Since I'm solving for a side length, I set up the law of sines proportion with side lengths in the numerators. B over the sine of 35 equals 165 over the sine of 83. Solving for B gave me 95.351 feet. Great! The rope will reach Mia to help her cross the river. Here's another problem. A boat leaves port and travels 8 miles to an island. It then leaves the island at an angle of 56 degrees away from the path at which it arrived and travels 5 more miles. How far from port is the boat now? Oh, and here's a reminder. With problems like these, unless you're told differently, you can assume that lines like the one the boat travels in are straight. Thanks, Mia! Since this problem didn't come with a picture or diagram, our first step is to draw one. Draw out what you know, label any measurements you were given, label the measurement you're trying to find, and then make a game plan. We'll walk through that process together, but if at any point you feel ready to tackle this problem on your own, feel free to pause your video and give it a try. We start with a diagram. Here's the shoreline with the port at point P and the island, which we'll call point D. The boat traveled 8 miles to get to the island. It then left the island at a 56-degree angle from the path at which it arrived and traveled 5 more miles. How far is the boat, point B, from the port? Which trigonometric formula will help us find the length of side D? Yes, we have 2 sides and their included angle, so we can use the law of cosines. Pause the video now and determine the boat's distance from the port. Here we go. The general law of cosines is here for reference. We're finding side D, so D squared is equal to 8 squared plus 5 squared minus 2 times 8 times 5 times the cosine of 56. Running all of this through my calculator, I found that the boat is 6.653 miles from the port. Is that what you have? Nice work! Here's the final question to answer. A developer wants to build a multi-story building that will serve as artist lofts on a triangular plot of land. The plot of land measures 38.6 meters on one side, 41.5 meters on another, and 24.2 meters on the third side. How many square meters does the developer have to work with? Try drawing a rough sketch of this plot of land and determine which theorem or formula you've learned that will help you answer the question. Welcome back! We don't know anything about the angle measures of this triangular plot of land, but we can draw a rough sketch of its shape. While your sketch doesn't need to be fully accurate, it's always a good idea to try to have the longest side labeled with the longest measurement, the shortest with the shortest, and so forth. And which formula do we need to determine how much land the developer has? Right! Heron's formula finds the area of the triangle when we know all 3 sides. S, or the semi-perimeter, is 52.15. Carefully substituting values into the formula and popping everything into my calculator gave me an area of 458.63 square meters. Great work today! Let's summarize our work with some problem-solving steps for triangles. Step 1 is to draw a diagram and include labels for all known and unknown values you're trying to find. Next, look at the diagram and the unknown value and determine which trigonometric formula or formulas you will need. Remember, the laws of sines and cosines both require 4 values. If you know 3, you can solve for the 4th. Finally, substitute those known values into your chosen formula and solve carefully, making sure to check your calculator's mode for either radians or degrees. Now that you're done with the video and guided notes, remember to finish the lesson activities before completing the wrap-up assessment. And I'll see you next time. Hey, hey.